Oh, hey. So today we are continuing with radicals. Today we're talking about rational exponents. So what that means is when the exponent is a fraction. So instead of having like 3 to the third power, it's having something like 3 to the 2/3 power. That's called a rational exponent because the number up there is a rational number or a fraction. What we're going to focus on today is converting between between radical form and exponential form and simplifying where we can. All right. So the third formula that you have on your little notes here on radicals says that if you take a root like n root a, that n on the outside, that index, you can rewrite it as a fraction exponent. You just put whatever's on the outside, that index, you just put it on the bottom. So if I had something like the cube root of 7, I could rewrite that as 7 raised to the 1 over 3. Now, sometimes there is a exponent on the inside as well, like this might have a 4, well then that would just go on the top. So whatever the exponent is stays on the top. Whatever the index is, whatever root you're taking, that number goes to the bottom. So lots of blah, 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 blah. Let's actually see that in action here. Let's look at a couple examples. First of all, 8 raised to the 2/3 power. If I want to write that in radical form, then I need to move that fraction. That 2 stays on top, so I still have 8 squared. But now that 3 comes right out here. It doesn't go in front of the root. It becomes the index of the root. It's that little number that goes up in the root. So this becomes the cube root of 8 squared. Well, you know that 8 squared is 64. And what you learned how to do last time was if I take that 64 and I break it down, that's 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So last time you took all of these 2's and you rewrote this. You said, okay, the cube root of, let's see, there's 1, 2, 3, 4, 5, 6 of them. And you're looking for pairs of 3 because we're doing the cube root, which means you get to pull out 2 groups. So you get 2 times 2, and you're not left with anything on the inside. Do not put 0 there. Remember, when you factor out, when you're dealing with multiplication and everything goes away, you're not left with 0. Technically, you're left with 1. We just don't have to write it because timesing by 1 stays the same. So all I have is 2 times 2, which is just 4. So maybe this is one I should have tried putting in my calculator, which you can do. You can go to Desmos and you can say, all right, 8 raised to a fraction. I can say 2 over 3. Nope, I missed a button. 2 divided by 3, right? 8 raised to the 2/3 is 4. So maybe before you simplify, type it in the calculator, see if you get a nice number. Because if you do, then that's the simplified answer. Okay, number 2, a lot messier than number 1. And I forgot a parenthesis right there. So 32, x to the 12th, y, all of that is being raised to the 3/4. I got to get rid of that fraction. And to do that, I take the 4, and I'm going to actually start writing up here a little bit. I take the 4, and that goes on the outside. That's my index. And the 32, x to the 12th, y, still has the 3 as an exponent. The 4 moves to the outside. The 3 stays on top. Now, simplifying what you learned last time, well, I guess 2 lessons ago, this 3 gets distributed to everything on the inside, right? So this actually becomes the 4th root of 32 cubed x to the 36, because you do 12 times 3, and y to the third power. Okay, 32 cubed. You are welcome to type that in your calculator, and you're going to get a great big number. I'm going to do it a little bit different because 32 cubed is just 32 times 32 times 32, right? Well, I'm factoring those out, right? I need to break them down. So 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So each of those 32s just turns into 5 regular 2s. So if I rewrite this, I get 2 times 2 times 2 times 2 times 2. There's my first 32. And then I need 5 more. 4, 5. Then I need 5 more. Oh my heck. Then I've got 36 x's. So I've got a whole bunch of x's. And then I've got a y and a y and a y. So that's a lot of numbers to group and pull out, right? If I start with my 2's, now I'm looking for groups of 4. So if I start with my 2's, I've got 4, 4, 4, and then I'm left over with 2. I'm left over with 3 2's. But at least I can pull out those 3 groups. So those are going to go out in front. So I'm going to get 2 times 2 times 2. That's going to go in front. Now my x's. If you need to write 36 x's and group them up into groups of 4, you are welcome to. But you've been to elementary school. You know that if you're taking 36 and you're breaking it up into groups of 4, that's the same thing as doing this. 36. Nope, not that. That's the same thing as doing 36. Oh my heck, where am I? Let's start a new one. 36 divided by 4. I'm just breaking it up into groups of 4, and I'm going to get 9 of those. So I'm going to have 9 groups of x's that I get to pull out. So I'm going to have x 9 times. 2, 3, 4, 5, 6, 7, 8, 9. Holy cow. And I'm not going to have any left over, right? Because those are perfect groups of 4. And then I've got these 3 y's. Well, I need a group of 4, and I only have 3. So those don't go anywhere. So I'm left over with 3 2's and 3 y's on the inside. Oh, man, that's a lot. Okay, 2 cubed. 2 times 2 times 2 on the outside. That's just 8. X 9 times. That's just x to the 9th. And then I've got my 4th root, and I'm left over with, on the inside, I've got 8 y to the 3rd. Now, there are a lot of places right there you could take a shortcut. You don't have to write all of the steps out, but it might be a good idea to, especially on your first 1 or 2. Hopefully, last class period gave you a lot of practice taking those groups and pulling them out. So that would be my final answer right there. Okay, number 4, instead of writing it in radical form, it wants me to go the other way. It wants me to simplify, but it wants me to write my answer in exponential form, which is really easy to do. All I do is take that 4, put it on the bottom of the fraction. So that just becomes q raised to the 15 over 4. And I'm done. That is exponential form because it has an exponent and none of them are negative, so that's good. Well, I guess it's more important that it's on top than that it's not negative. So yeah, that's as far as I can go with that one. Let's do one more example because that you might see something a little bit more complicated than that. So let's do something like, let's say 1 over, I don't know, let's say the 6th root. I don't think we've done a 6th root yet. And on the inside, let's do something like 3w. We're going to raise that to the 11th. Now, that 11, this is the same thing as this. And this is something that confused me when I was in school for a while. It doesn't matter if the 11 is on the inside or the outside. Because either way, you're just multiplying the same thing together 11 times, right? So it doesn't matter which way it presents it. I prefer this way, but a lot of books like to write it that way, so you may see it. Either way, it's an 11, okay? And all I need to do is leave that on the top. So I still have my 3W, but I have an 11 on the top, and that 6 comes to the bottom. Oh, but, whoops, Mr. Reed, that's on the bottom of a fraction. So I have 1 over 3W raised to the 11 over 6, right? I would be okay with that answer because I like positive exponents, but typically when you're putting answers in, a lot of times it doesn't want this exponent on the bottom. So it might want you to rewrite it as 3W. And if you remember to change that 11/6, to move that to the top, all you have to do is make it an 11, a negative 11/6. And now it's on the top of the fraction instead of the bottom of the fraction. And I have a feeling sometimes that might be what the answer key wants. It might want it written in that form. I will accept either way, but it might want it written in a specific form. Go ahead, look at the homework problems. If you want to try a couple at home, go for it. We will spend class together. We're going to do some examples at the beginning of class. We are going to try some that are a little bit more complicated together, and then you will have time during the class period to finish up the homework.